Hi there, Neil McGee with the UVA School of Data Science. In this little webcast, I'd like to go over two automation tools, two orchestration tools that you might encounter in the real world beyond UVA. And things that I don't, the courses try to expose you to a lot of basic tools and slightly more complex tools, command line, get and versioning your code, some basic scripting, worrying about the environment around your code and how do you support that, how do you support all the packages and libraries you need, how do we talk to databases for pushing data and pulling data and recording it for us, what are options for storage, what about using APIs and creating APIs and so on. So we've done a lot of work around that. And this is sort of to give you just an exposure to two concepts, not even to expect any sort of mastery over them. And it's also a nod towards Systems 2 that the BSDS students take in the fall of their third year at UVA, their second year in our program, where we really work on scale and automation. And so all sorts of things that you just, in the industry context, there's just so much data and so much to do. You don't really set up too many things and run them by hand. You test and you develop by hand, and then you kind of set it into automation and into production. And so these are two things that I want to show you for production. And we'd call these orchestration tools. I would call them orchestration. And they're different conceptually. And the first one is called Airflow, and it comes from Airbnb, actually. It was an internal tool that they wrote to manually walk data through, or to automatically walk data through a data pipeline, through a workflow. And they wrote it to be sort of an abstract task engine so that any data scientist, any engineer within Airbnb could write a flow that does what they need it to do, and then set that up on a schedule and just kick it off and let it go. And Airflow was contributed to the open source community, so it's an Apache project, which is great because many, many people outside of Airbnb now use it. Many, if not most, large companies use it as the data pipeline orchestration tool of choice. And again, as I've said with every tool, that may change over time, and there may be the next Airflow may be named something completely different and do even better work at this than Airflow does. But the concept will remain that it needs to gather data, walk it through a particular set of flows, come up with a certain result or results, maybe have some complex logic in there and so on. And so the job won't go away. The second tool I want to show you is called Kubernetes. And Kubernetes was developed internally at Google. It's a container orchestration framework. Basically, the question was, well, we have this concept called containers, and Google was using them before Docker even came around. They were really obscure and pretty complex to work with, but Kubernetes was developed internally, called the Borg at Google, and it was a way of just running code in isolated little pods, we could call them, and that's what we refer to a container in Kubernetes as a pod. And so Kubernetes gives us an option of deploying long-running containers, short-lived ones just to do a specific job. We can put them on schedules and so on. It's a bit more direct and less. It just does exactly what you tell it to do per container, and you can put in environment variables and so on. So it's a little less workflow-oriented and a little more just, here's this thing, I need it to run. And we'll get to that in a second. So this won't be too long. I just want to walk you through a few basics of each of these tools. And then you're going to do a lab before the end of the semester on Airflow. You're just going to dabble on it locally. So I'll send you this page. You can read all about Airflow. And the idea is that your workflows in Airflow are based in code, based on a concept we've touched on before, which is the DAG, the Directed Acyclic Graph. And the DAG is just as you'll see in a second with a simple example I wrote, it's just a series of tasks that you tell it to run. So the first thing is you're going to clone a repository that I'm going to give you, and I want you to install, per the instructions, install this command line tool called Astro. It happens that one of the best Airflow companies that sells great products and support around Airflow is called Astronomer. So the folks at Astro wrote this example engine that we're going to use, and we're going to run a DAG on top of it. So you clone the repository, CD into the Learning Airflow folder, and you're going to see there's a Docker file. There's this .astro folder that has some special things in it. The DAGs, which is very important. This is going to be where we put our Python files that are going to run these are our actual DAGs in the form of Python files. And then really the only other thing you need to worry about is requirements.txt that's just got any packages you need in it. And so once you've installed the command line, you'll just say astro dev start, and it's going to start up 4 containers. Here they are. It's a Postgres database container, it's a triggerer, a scheduler, and a web server. And they're all running together locally on your machine. And it's gonna say starting up, and it's gonna give you some credentials if you want, if you wanted to log into the database server and so on. Most importantly is it's going to open up the URL to the web server and tell us that the username by default is admin and the password is admin. And so you can sign into the web interface using that. So let's wait for this to go. There we go. And now we're into Airflow. And you'll see, I'll just move this over here. And I'm going to turn this one off for a second. We'll get to that. Let me just orient you quickly to the board here. So the main thing we want to look at are DAGs, and we could have hundreds of DAGs. Companies will have many, many DAGs. You can enable them, you can pause them and unpause them here. You can get your list, and you can filter and search and so on. And each one is a series of tasks. And so the one that comes built in is called Example Astronauts. And here's the run schedule. Here's the length of time that they've taken to run, which is just a few seconds. You can see somewhere between 7 and 15 seconds. It's had 22 successes. It shows us a graph of what's going on inside of this DAG. And this DAG is actually created, the folks at Astronomer wrote it to query an API and get the exact name and number of astronauts who are in space at any given moment. And there's actually a place that tracks this. So when people arrive and depart the International Space Station or the Chinese Space Station, those names are always known and registered. So this basically is just a proof of concept. It'll show you a Gantt chart for this. It'll show you the code so you can go read it, the event log, the duration of everything that it took. Something took a while for some reason. And the task duration and so on. So that's nice. We can go up to DAGs and see that. And we can see that this is on a cron schedule, so that it's every minute divided by 5. So that means every 5 minutes it's going to run, every hour of the day, every day of the week, every month of the year, and so on. And it's had 23 successful runs. It's probably not going to kick off while we're here talking. And I can come over here and I could run it by hand. I could trigger it. And you'll see if I do that, then here's one getting queued, and then we should see it maybe getting in the running state. There it's running. And then after a few seconds, it'll come over and this should show 24 successes. There we go. So that's that. And I could delete it. I could refresh the DAG if I want to, and so on. What I'd like to show you is a simple DAG that I wrote. And you're going to be deploying a simple DAG of your own and in the lab. And here's the code for that. There's a lot of interesting Airflow imports. And what I've done is just go right into my DAGs folder here, and I've just written a file, simple dag.py. And then I've got requests because I'm going to make an API request. And then I've got these familiar imports. In fact, I don't even need Boto 3 anymore. That was a test I was doing. But I've got MySQL connectors, and I've got PyMongo connectors from our previous 2 labs. And then notice this, I've got my Mongo connections, and I've got my MySQL connections, these variables that we need for the connection strings. A little side note is that you'll see instead of the environment variable, I'm going to get a variable from from Airflow. So it's variable.get, and then it's called this. And I can come back over to my UI. And here under admin, I have variables. And I can just set a variable, fname, I like all caps, and I could just say Neil. And I could save this. And now this is a variable, and I could encrypt these and so on. This is a variable I could now pull out in my code simply by saying, fname equals variable.get. And there. So my GitHub Copilot is helping me recognize that. So that's the way that I pass sensitive information in, like a password or an API key or so on. Again, I never want to code that into my code that I'm going to push to GitHub or anything like that. I want to store that as a variable here. And what's great actually is I can put that as a variable here, and many of my different DAGs could use that same variable. It's great. If it's AWS keys, then I can use those repeatedly throughout my many DAGs. So that's the first thing, and you'll notice in Mongo I'm creating a new Airflow database called Airflow, and within that I'm creating a collection called jokes. Okay. And then in MySQL, I'm using my database called nem2p. And then we get to the kind of the heart of the DAG, and the DAG has sort of this header information at the top. It has a start date, which I could put in the future. This is way in the past, so that just means it's fine to start now, but I could schedule this thing to start. I'm sure I could give it an end date as well, and I could say, hey, just for the month of November, run this every day in the month of November, and that's it. And then I can set up a schedule, and this can use different syntax. I can give it cron-like syntax, or I could say, there's a way that you can say the schedule should be hourly, once per hour, or 2 times per day, or whatever, and it'll figure out the math. Maximum, if it fails, how many times to run, who's the default owner, how many times should I, what's the retry, delay. I can give it some tags and so on. And should it be paused when I create it, true or false, and so on. So that's fine. And then the rest of the DAG, so that's a decorator. Notice that whole thing is just a decorator line with this @ symbol. It's decorating one big function called simple. And you'll notice at the bottom I invoke simple. And within simple, there are 2 tasks. Here's the first task. Here's the second task. And these are likewise, these are decorators to functions. So this decorates the getJokes function, and this one decorates the MongoJokes function. And what I do in each of these functions is whatever I'd like to do. And notice, so I get here, and this is just going to use the context of the execution. So we leave that context symbol in there. And I'm going to do a try and an accept and a finally. I don't even need this code at all because I've tested that and commented it out. And I do my normal, I'm going to do a normal like API fetch, and I'm going to go ahead and get a random joke. Again, hardcore data science here when we're handling jokes all the time. And there's 2 bits of data. I can grab that URL and I can go and I can show you. It gives me a type and a setup and a punchline and ID. That's great. I really only want 2 of those pieces. So I look for a bad status. I get the setup value, and I get the punchline value. And I'm going to just do a simple insert in MySQL using insert into the jokes table, the setup and the punchline. And I'm going to commit that and so on. And then basically to have an exception, and I'm going to close my cursor and close my DB, just like we did for Data Project 1. The one special thing I am doing, however, is I'd like to pass the output of this function into the second function. And there's lots of ways I could do that. I mean, I could write it to an external database, and I could have this second process fetch from that database. I could find out a text file or an S3 or something. I could send a file somewhere. I could have Redis available locally. That would be pretty handy. Just to have a Redis container running in my cluster here, and I could actually send and receive data. And in a way, I have an option of a key value store here built into Airflow, and it's called the XCOM tool. XCOM is sort of cross function and cross-DAG communications. That's what your X stands for, cross communications. And I can set up a context, and I can basically create a key with a value, and I can push that. So this is just like a Redis push. And I can have a key value for the setup, a key value for the punchline. And both of these are pushing that value. And then I come to my second task, which is, here's my decorator for Mongo jokes. It's going to receive from the XCOM, and it's going to use the context. And basically, look at this. For my setup, I'm going to XCOM pull the setup key, so I'll get that value, and for punchline as well. And then I just do this one great line of Mongo, where I'm going to insert one, and I insert the setup, and I insert the punchline, and I print out this statement. And then within this whole within simple, I'm going to say, hey, call Mongo jokes, and to execute Mongo jokes, call the get jokes function. So I'm kind of wrapping one function within another on the call. And that is it. If I save this and I come over here, I'm going to ask it to reparse my DAG. Let's hope I didn't mess up anything. Notice that I have it on a schedule of running every 10 minutes. And I'm going to turn it on now. And you can see that my reparsing request submitted. Okay, so that's fine. I've got my variables configured so that it knows my passwords to my two databases. And now let's just go ahead and execute this by hand. So we'll see 1 is now running. It takes just a few seconds to run, and now it comes over to 5. And that's done. And what I've just done was, here I had 2 jokes already in the table. I think I might be up to 4 or 5 now in the time I've been talking. So I browse for that. Yeah, so now we can see we're up to 301 is my ID. And then I come over here to my cluster of Airflow jokes, and if I sort over here, I've got, yeah, they wanted to hit the right C's. That's the final joke that I have. But we can see if we run this one more time. Running. This should not take long. It's a pretty quick little operation. Now we're up to 6. We can see we have a new joke. What do vegetarian zombies eat? Grains. And I should get that as well over here. Great. So that's it. I mean, that is a very simple proof of concept sort of DAG. You can imagine here a lot more tasks that are going to do all the normal things. They're not just going to be kind of a ha-ha proof of concept with a joke and so on. But they might be fetching complex data from a source, let's say S3. It's going to pull the file from S3, 10,000 lines long. It's going to clean that file up, and maybe it's going to post it to a new bucket or a new location. And it can pass that new location on to the second task. And the second task is going to take that file. Maybe it's going to do some basic diagnostics on the data, some basic analytics. And it's going to store those somewhere else, or it's going to render a crude plot for somebody to know the quality of this data, or run a bit of filtering on it, and then so on and so on. So what's nice is that this is just a flexible framework, so I can have multiple tasks. I can have conditionals within each task that say, hey, if this succeeds, proceed to task so-and-so. If this fails, go to this other task. I can also have cross-DAG communications so that one DAG can actually trigger another DAG. I could have, and in that way, it's almost like programming, like building blocks. I could have one DAG that just does a very, very common task, and maybe it just takes a couple parameters. Well, I can have another DAG that's running, and if it gets to a certain point in its logic, it can just call that other DAG, feed it the parameters, and it will run in turn. So that's the great thing here. And we can schedule these on a normal schedule. We can run them ad hoc whenever we want to. And so I want you to recognize Airflow as a rich and complex and very robust. I mean, we could easily spend a whole semester just learning Airflow and having a pretty strong capabilities with that. Because there's just all sorts of other options. They have data-aware DAGs now, so that when a particular data event happens, maybe a file arrives in S3, maybe a new row is added to a database table, that too could trigger DAG. So we're getting the idea of event-driven computing even inside of Airflow. So follow the steps for the lab for this one. That's your final lab for the semester. And then let's shift over to just show you a bit about Kubernetes. Hang on. Okay, we're back. So we're looking at a dashboard using a tool called Lens to peek into a Kubernetes cluster. And UVA, my old team, in fact, from the research computing group, runs a cluster, a pretty large cluster, as far as these things go, large for UVA, maybe 25, 30 servers. There's some GPU nodes in there, a lot of memory, a lot of CPU. And at the moment in this particular namespace, this particular little sandbox I have created, we're running 14 pods, which means 14 containers, 6 different deployments, and you'll see what that means just in a second, replica sets and jobs and so on. So what's nice in data science is that we could have the idea of a job, and I'm just going to show you a really, really simple job. And so just so you understand the setup here, we have a GitHub repository that describes all sorts of deployments. And we just describe these in YAML using the syntax that Google's sort of the Kubernetes, the community described. And I'll walk through that in a second. But the nice thing is we have a connection between GitHub and the cluster. And it's called Argo. And this is this little tool called Argo. It's web-based. And it basically shows me everything that's running in my namespace right now. So here's the top level namespace, and then here's all these deployments at this level. And then they have what's called replica sets after that. That's just trying to manage the pods. And then here are all the actual pods running. You can see I have some fast API demos. I have an ID generator, and so on and so on, just as test deployments. What's nice is that this is running something called declared state. And declared state means I, in my YAML, declare how this thing should run. I want, I want this container image to run, and I want this command to run, and I want it to run at the top of every single hour all the time. Here's how much memory to use, here's how long to keep the logs, and so on. And we call this a spec file, a specifications file. And so let's say I have a deployment of maybe this ID generator, and I've said ID generator should always run 2 copies, always. And so even if I come over here and I delete this, I force it to delete, look, instantaneously a replacement has already been created for it. That's just a few seconds old. The first one will finally get deleted only after the new one is online. And so what we'll see in a second here is that the new one's online. Here's this old one getting deleted with the little circle, and it will go away. And so you can understand how for a company like Google, they want to say, hey, we need the following services up at the following levels. Make that happen. And declared state means that the cluster just figures out how to make it happen. And so let's just describe this little job. And I'm going to take all this and I'm going to remove the comments. And this is a cron job. And we give it a name. So it's called pi calculation. And we give it a namespace. So it has to run in this namespace, which we own, amongst many, many other namespaces. It's got a schedule, and then it has this, the rest of it is all just a template. And then we call it the PyCalc pod, and it should run a Perl container. Perl is the practical extraction and something of language. It's a super old text manipulation package that came in Unix ages ago, and it's still quite useful. We're going to use Perl just to run a command that's going to actually calculate pi. And we're going to give it just fractional. Look, a half of a CPU and a half a gig of memory. That's barely anything. So you could put thousands of these things in the cluster. And then we'll keep the logs for a day. I can just say git status, git add, git commit, the pi pod. And I push that to GitHub. And now I can come over here, and we'll probably have to fast forward the video. Argo is trained as this intermediary to look at the GitHub repository every minute or two. So this will sync up in the matter of a couple minutes. I'm going to go ahead and kick off a sync to kind of force that to happen, so the magic of recording can be a little briefer than that. So let's come back in a second when this is launched. Okay, and we're back now. You can see this is synced up, and it says re-enable the Pi pod is there. And if we scroll down to all the deployments, you'll see Pi calculation as a cron job has been launched. And then when we go back over here to Lens, I can look at all of my running pods. And notice this, it's having a hard time actually deleting that pod that I was trying to delete. It brought up the new one 6 minutes ago. It's not cleaned off the old one, but what's great about a large orchestrator like this is that has no bearing on all these other pods or the hundreds of other pods running on this cluster right now. So they're all quite isolated from one another, and there's no kind of damage caused by a hung service. So I'll go ahead and take care of that, or I might just wait a day, and it'll probably be cleaned up by the cluster itself. I can go to all my deployments and so on, but if I look at cron jobs, here is my Pi calculation, and it's scheduled for the top of every hour. And what I can say is trigger this. It's going to suggest a name for me, trigger it. And then when I go up to pods, you'll see here's the Pi calculation. And I can click into that. I can get the pod logs for it. And here is the 3.14. Here's my incredibly long log output for it. And then you'll notice that this container has now gone away. It's succeeded. It's no longer active because it did its job, it ran, and now it's gone away. And I told it in that final spec line, hey, how long, what's the time to live after finishing? How long should I keep that? And that's a day, a day's worth of seconds. So the logs get kept around. So again, you can imagine how this doesn't do like Airflow where I can have this job handed to this job and so on. But this is going to run something for me, a command or a particular container that does something. It could run Fast API or another sort of API. It could run a Mongo database for me. Other long-running services that just stay up and running all the time, and we call those deployments. Keys, here's a DP1 test I was doing, here's an ID generator, here's a Fast API. Databases could be the same sort of way. Or I can do this sense of jobs and cron jobs that are scheduled to run. So the idea here is this is a bit more abstract in terms of just raw computing. This will do what I want it to do. A very common model I will use is to have one long-running pod that cycles every 60 seconds, and it looks for a message in maybe the simple queuing service in Amazon, and it parses that message, and based on what it sees in the message, it then knows what other container to kick off. And so I sort of call it air traffic controller. It's like it's seeing these messages come in through the queue, and it sees, oh, this message belongs to the, maybe we have the apples, blueberries, and cherries, different services, and it sees, oh, that's an Apple message, and here are the parameters for that message. Let me kick off an Apple deployment and pass those parameters in, And so it can sort of triage what it sees coming in and then kick off these other jobs. This is the way that we run really, really robust, large-scale deployments, is just by automating these sorts of things in the background. What I love is that this is called infrastructure as code. Well, it's really deployments as code of this declared state model, where I just worry about my YAML here. I am never shelling into a server to run a command. I'm never worrying about installing this package or that. It's all taken care of in the container itself. And so this just handles it for me. So that's just a quick, brief overview of Kubernetes. You're not going to use that this semester. You'll use it for sure in the fall of your second year with our program. Thanks so much. Hope you have a great break. I'll see you in December.